We meet a lot of companies who want to make use of artificial intelligence to allow an algorithm to help themselves in their inspection tasks faster and better. This often makes good sense, and the recent developments in the AI space have paved the way for a number of commercially available standard AI platforms. These neural networks can solve tasks such as object detection, anomaly detection, classification, and optical character recognition. They're nice standard models to have, especially if you are not so concerned with your rejection rate. However, there are also a number of pitfalls associated with using these standard AI models, and I would like to go over these in this video. First of all, one of the problems in utilizing standard AI models is the lack of control over how the model trains. It is very important to choose the right network model or architecture that is the best solution for your problem. Especially if you work in pharma where errors are critical, it is important to research the different kinds of network architectures to allow you to get the highest precision possible and choose the model that works best for your problem. The second pitfall is about annotation. The learning material or the training data is one of the cornerstones of a good AI model, and if you treat it badly, it will impact your entire model and the entire performance. For example, the AI model will always consider the ground truth or the label data as the absolute truth. If you tell the network that a dog is a cat, for example, it will just trust this completely, and it will lead it to becoming confused and lead to a suboptimal network performance. Furthermore, when you annotate pictures, there are some standard AI models today that can give you suggestions for the next 100 annotations based on the first 100 annotations you have made. And while this may seem tempting because it can save a lot of time, it's actually a huge no-no in deep learning because you just got 100 new suggestions based on the first 100 suggestions. And actually the network wasn't really being given anything new to learn from. For that reason, we make sure that we are as concise and involved as possible when we annotate pictures here. The third pitfall regards making a bad weighting of the classes. If you have multiple classes and there is one class or error that is occurring much more frequently than the rest, this can lead to the network training disproportionately much on that one error, which can lead the entire network to be skewed and not performing optimally. So it is important to weigh the classes properly. The fourth pitfall deals with not following good deep learning and AI practices when training your network. Essentially, some standard AI platforms here just accept a big pool of data that you train on and then you get a solution back. This is actually a big no-no in deep learning because you need to split your data so that you don't validate and test on the same data that you have trained on. When validating and testing, we must make sure that the network is exposed to completely new types of data that had no impact on how the network was trained. Otherwise, this will lead to the network not being able to generalize well to new types of raw inputs. Doing deep learning the right way is of high priority when we build a custom solution. Finally, for the fifth pitfall, it is not uncommon to encounter a new type of class or error that you would like to add to your network, so you can continue working with 4 classes instead of 3. In some standard AI platforms, you will have to start completely over from scratch and retrain your network when adding a thing such as a new class to a network. But it is actually possible to add the new class without having to start over from scratch or retrain your network. This is often what we do when we encounter such a case when we're building a custom solution. So to sum up, standard AI platforms can be great for many straightforward tasks as long as you keep an eye on the limitations that come with it.